Here's how I suggest formatting your homework. Of course, put your name on it, which chapter you're working on, and if you got help from anyone, like the math tutoring lab or a friend or relative, you can list their name here, or if you worked with other people in the class, list them here, please. And then I'm saying put a big old dividing line right down the middle, and on this side you put your work, and on this side you do what I call an evaluation. And the work might be like, okay, number 97 in the textbook is maybe the integral 0 to 1 x squared plus 3 dx. And then you take antiderivatives, etc. So you might say capital F of x equals blah, 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 blah. And over on the evaluation side, you show however you double checked the answer you got over here. So there's a bunch of ways you can do that. You might check in the back of the book. That's kind of a boring way to do it, but I guess you can do that. You could say that you went to Desmos and you typed in that integral from 0 to 1 and you got 3.333, and that matches your answer from over here. That's a good way to do it. You might draw a little picture and do something about that I'll call upper bound, lower bound, and guess that I'll talk about later. That's another good way to do it. So the point here is that you're checking your work as you go along. So if you've got a conceptual issue with something, you find out right away before you go on to the next homework problem. That way you're not waiting to get feedback from me on whether you're getting the right answers or not. And then once you do the work, if you do the work, do the evaluation and find out that it doesn't match your work, what I would do is cross out the work kind of gently. You don't have to really scribble it out. I wouldn't erase it. Just cross it out and then do new work and do a new evaluation. It's often helpful for our own learning to see what we tried, what didn't work, figure out why it didn't work, keep that written down so you can refer to it later, and then eventually what did work. Once you finish a problem, I would draw a horizontal line and then say, okay, I'm moving on to the next problem here, and whatever problem that is. So that keeps all the work in a nice sequence. So the evaluation does not have to be super exact. It just has to be something that gives us some confidence that that the work was going well. So for example, when you sketch something like this, you don't have to put all the like X marks and Y marks and stuff. I really don't want you to spend a lot of time on the evaluation, but it's a way of making sure we're going along the right track, and maybe even getting a different view of a problem, where if you did this one with formulas and you did this one with graphs, then you're kind of comparing those. Let's go talk about this upper bound, lower bound, and guess idea. Let's say we had that problem, integral 0 to 1 x squared plus 3 dx. Often the first thing I'd like to do is graph it, so I'd put down a graph. I'm going from 0 to 1. Here's 3, and it's some kind of parabola, right? Ends up at 4 there. I want kind of some guardrails to say what kind of number do I expect to get here. So what I might do is start with an upper bound, and I'll do that in blue. Well, you could say if this function was as big as 4 the entire time, so I'm kind of approximating this complicated curved function with a plain old flat line, and saying if it was 4 the entire time, then that area would be a height of 4 times a width of 1 minus 0, which is 4. Okay? That's an upper bound. In math, it's often helpful to say, you know, for a complicated problem, let me do some simple approximations of it. Not only does that help me check my answer at the end, but it also helps me think about the problem as I'm doing it before I get to the complicated part. A lower bound, there's actually two common lower bounds. The really simple one is to say, well, what if this function, which is all positive, was just 0 the whole time? So that would be a height of 0 times a width of 1 minus 0, which is obviously just 0. And you don't even have to write out that that's what you're doing. But if it's a function that's always positive and you're integrating it forward, you should get a positive answer, right? So a quick lower bound would be 0. A better lower bound would be to say, well, the smallest the function ever got was 3. So I'm going to draw a horizontal line at 3 and think about a box like that. So that would be a height of 3 times a width of 1 minus 0, which is obviously 3. All right, so now I have kind of some guardrails, right? If I get an answer that's 29 or negative 15 or something, I can say, wait a minute, I must have done something that wasn't quite right. What else can we do when you're driving or riding in a car? Hopefully you aren't right up next to the guardrails all the time, right? Hopefully you're kind of in the center. So there's something that you could call a guess or an approximation. And the simple thing to do is just say, what's the lower bound plus the upper bound divided by 2? Here that would obviously be 3.5. Is there a way we can interpret that guess or approximation graphically? Well, the width is the same, so it's really just the heights that I'm averaging. So I can draw a line here like that. And the area of that rectangle is my guess. And then I can think about interesting things like, do you think the guess is larger or smaller than the true area of the under the curve here? So just looking at that picture, it looks like the guess misses some area here, but includes a lot of area that it kind of shouldn't. So I think the guess is actually, let's see, guess is larger than the actual area. Another interesting way to see that is, for this guess, I can think of it as a straight line that cuts this upper rectangle in half, or I can think of it as pivoting that purple straight line through the center there and getting more of a triangle, and then because the triangle is another way to cut that rectangle's area in half, right? And then once I draw that, I can see, oh yeah, that's always above my curved function, so the area of my guess is going to be above the actual area. So that's upper bound, lower bound, and guess. I really like them. Most calc professors don't have this idea. They can especially help in three-dimensional problems that we'll get to where we're spinning things around an axis and asking about volumes. You can do an upper bound or lower bound by imagining a cylinder containing that thing. The downside to upper bound, lower bound, and guess methods is they're all aimed at getting a number, or like getting guardrails on a single number. And a lot of calculus should be about like rates of change, how much things are changing, how much they've changed so far. It should be about functions through time rather than just single number answers. So while I like upper bound, lower bound, and guess, we have to remember that they aren't everything in calculus. Just getting individual numbers is not the main goal. The main goal is to understand change so far and rate of change and stuff. So it's good to keep a balanced view of that. So with upper bound, lower bound, and guess, you can do all that stuff in the evaluation column. Really, if you end up doing it over here because you already drew the graph over here, that's okay with me. I'm not too picky about exactly what goes in which column, but just the idea of doing evaluations and kind of keeping nice, neat columns is nice.